Otherwise, I'm going to just break down solving simple basic trigonometric equations. So I'm going to start by linking the equation, would help if I had a pen that worked, linking an equation with the graph. And I'm going to go back to what we learnt when we were in year 9 trigonometry. So let's just talk about cos x equals 0. This is a basic equation that we need to be able to solve. So when we were doing trigonometry in year 9, to find the angle in a right angle triangle, we used to use the inverse of cos. So we'd say inverse cos of the answer will give us the angle. And when we type that into our calculator, if we were saying degrees, we would get 90 degrees. Now, this is still a valid way of solving trigonometric basic equations, only what we need to do is consider what happens if we don't have the calculator. And we've got things called boundary angles or exact values. So I'm going to just still remain on this solution. I'm going to just draw to the graph. So what I want to do is solve this equation. I haven't set a domain, so let's do that first. All your questions will have a domain set. So let's set between 0 and 2 pi for x. Okay, so that's just one period of a normal cos graph. So if I draw a normal cos graph, and I'll place on the graph the key features. Okay, so on the y-axis we've got 1, 0, and then down to -1. And on the x-axis, if we stick in, I've gone 0 to 2 pi, but obviously I've answered the question in degrees. That was a bit silly. So obviously I'm going to go to 360. So let me do that. There we go. So my important key features on the graph sit at 90. Here is 180 degrees. Here is 270. And of course over here is 360 degrees. Now, let's have a look at what angles, so our angles are along the x-axis, what angle produces a y value of 0. So here is the line when y equals 0. So as I look along the line, the line meets the graph here. And this happens to be at 90 degrees, which makes sense because that's what the calculator gave us. However, the calculator only gave us the first solution. There are infinitely many solutions, but we've set a domain. And because we've set the domain between 0 and 360, we keep going along the line. And we see that the line meets the cos graph again at 270 degrees, hence being a second solution. So we would say the first solution is 90 degrees, and the second solution is 270 degrees. Now, let's bring it to the unit circle, because that's how I want you to be able to solve these equations. So if I draw up our unit circle, remember the unit circle is called the unit circle because the radius of the circle from its centre is 1. So if it's one unit, I can put some coordinates on there. If this is our x-axis and this is our y-axis, this coordinate here is 1, 0. Let's do what I call boundary angles. These are the angles where the unit circle meets the axes. So up here we've got 0, 1. Up here we've got -1, 0. And here we've got 0, -1. Now, what you should have learned with regards to the unit circle, that cosine is to do with the x-coordinate on the unit circle. So because I'm looking at when does the x-coordinate equal 0, we look along our unit circle. Well, the x-coordinate equals 0 here. Oh, this pen doesn't work, does it? Here. Let's go there. And the x-coordinate's 0 here as well. And remember, this is at 90 degrees. And this is at 270 degrees. So therefore, there are two solutions which we found on the graph, which make sense and work with the unit circle. I'm going to do another example now where I look at a special triangle. All right, now I'm going to solve sine x equals 1/2. And I'm going to do this without the calculator because we know I could use the calculator and it would give me an answer for the angles. We're trying to solve the angle. Now, let's work in degrees. Let's go from 0 to 360 degrees and find out how many solutions we've got. So, first thing I'm going to do is realise that I haven't got a calculator. This has to be an exact value. So I think about my special triangles and I think, okay, I'm dealing with sine. Sine, going back to our trigonometry days, the sine ratio is opposite divided by hypotenuse, which means in order for this to be true, this has to be the opposite and this has to be the hypotenuse. 1 over 2. So I'm going to form a special triangle that I know already that has a hypotenuse of 2 and an opposite of 1. Now, thinking back to this special triangle, we know it's a right angle through Pythagoras' theorem. We know that's got to be root 3. It was originally an equilateral triangle, which is formed with 60 degrees and obviously chopped in half. It's 30 degrees. You should already be familiar with this kind of triangle. Now, let's have a look at which of these angles, because remember I'm trying to solve, which of these angles gives the opposite as 1? Well, the opposite of this angle here is 30 degrees, right? 30 degrees is opposite 1, okay? So therefore, the solution for this is, first solution, remember, or it might be a solution. I'm dealing with sine is positive, so it's in the first quadrant, so it will be a solution. But x equals 30 degrees is my first solution. Opposite over hypotenuse gives me a half. Happy. Right, now let's go to our unit circle to get the other solutions that are within the domain of 0 and 360. So if I draw my unit circle, I need to put some important information on there. Let's put the angles on those boundaries. And remember that it goes anti-clockwise, and when I get to here, I'm back at 360 degrees, and it keeps going round and round and round. And let's remember which functions are positive in which quadrant. So, of course, we're dealing with sine, positive. Sine is positive in this quadrant and this quadrant. So I have, therefore, two solutions. We already know that this angle here is 30 degrees. So there is our first solution in the positive first quadrant. The second solution will lie in the second quadrant. And of course, we take the angle through symmetry from the x-axis here. Now all I need to do is 180, take away 30 to give me this other solution here, which of course is 150 degrees. So my second solution is 150 degrees. x2 equals 150 degrees. And that pretty much shows you how to solve. I might finish there actually, because this is 7 minutes long. Hopefully that gives you a better understanding.